All right, let's be honest. When you were a kid, you were probably at least a little bit terrified of the Bermuda Triangle, right? You'd imagine being on a family cruise, everything's going great, and then, poof, your ship just gets swallowed by the ocean. Well, today we're going to take that childhood fear and completely dismantle it, piece by piece.
I mean, this hits home for so many of us. We were fed all these wild documentaries and spooky books. But what if I told you the whole thing, the entire legend, isn't supernatural at all? What if it's just one big scam built on some really bad logic and even worse science?
So yeah, let's just go ahead and toss out all the theories about ancient aliens and sea monsters. We're going to tackle this with two incredibly powerful tools: data science and fluid dynamics. Our mission here is pretty simple: to prove, mathematically, that the Bermuda Triangle is nothing more than a place where some rough weather runs into some really bad statistics.
Okay, first things first, let's talk about the numbers. Because honestly, the entire legend is built on a very simple but really effective statistical illusion.
This is the one question you have to ask. All the mystery theories, they love to point at the raw number of incidents. They say, look how many ships and planes have just vanished here. But that's only looking at half the story. The real question is, significant compared to what? And here is the giant piece of context that always gets ignored. The Bermuda Triangle isn't some quiet, forgotten corner of the ocean. It's basically an ocean superhighway. We're talking about one of the busiest shipping lanes on the entire planet. Thousands of vessels are crisscrossing through there every single day. So what happens when you actually factor in all that traffic? Well, take a look. When you calculate the real incident rate, that's the number of accidents divided by the total traffic, the Bermuda Triangle doesn't even crack the top 10. Places like the South China Sea, the North Sea, they are statistically way more dangerous for sailors. You know, this mistake actually has a name. It's a classic logical fallacy called denominator neglect. Saying the triangle is cursed because of the number of wrecks is like saying a major city freeway is cursed because it has more car accidents than some quiet little country road. Of course it does. More traffic just means more opportunities for something to go wrong. It's not a mystery, folks. It's just math.
Okay, so we've dealt with the bad statistics, but what about the ships that do sink? What's really going on out there? For that, we have to switch gears from math to physics and the raw, absolutely brutal science of the ocean.
First, let's just get this compass myth out of the way. You always hear these stories about compasses spinning like crazy. The reality? It's a completely understood geographical feature called the agonic line. It's one of the few spots on Earth where magnetic north and true geographic north line up perfectly. So your compass points to both at once. It's not mysterious, it's just cartography. Now, let's talk about the real ship killer out there: rogue waves. The ocean in this area is a total hotbed for storms and is constantly being churned up by the Gulf Stream. So when you get multiple storm systems coming from different directions, their waves can interact based on a principle called constructive interference. And the physics behind this is actually kind of beautiful in its simplicity. When the peaks of two waves happen to line up just right, their heights, their amplitudes, they literally add together. So a 40-foot wave and another 40-foot wave don't just pass each other. For one brief moment, they can combine to form a monstrous 80-foot wall of water. And this breaks it down perfectly. You've got your multiple storm systems converging. Then, their wave crests align at just the right point in space and time. And the result? Their heights combine, creating a nearly vertical wall of water that can just appear out of nowhere, even in a seemingly calm sea. Just let that number sink in. 100 feet. That's a 10-story building made of water coming at you. That's not some sea monster, it's pure kinetic energy. It's more than enough force to snap a massive cargo ship clean in half. The ocean doesn't need magic to be deadly, it's got physics. But okay, what about the ships that vanish in perfectly calm weather? No storms anywhere in sight. Well, for that, we have to go deep, all the way to the ocean floor, for a quick lesson in thermodynamics and what actually keeps a giant ship afloat in the first place. So a ship floats because of a little thing called Archimedes' principle. The buoyant force that pushes up on the ship is decided by the density of the water it's sitting in. It's that simple. As long as that force is pushing up harder than the ship's weight is pushing down, you float. The key variable to watch here is rho. That's the little p symbol. It stands for fluid density. Now check this out. The seabed in this part of the world has these huge trapped deposits of methane gas. If a small tremor lets a massive bubble of that gas escape, it can shoot right up to the surface. Look at the difference here. On the left, a ship in normal, dense seawater, plenty of buoyant force. On the right, that methane bubble has turned the water into this fizzy, airy froth. And that all-important variable, rho, the fluid density, it just collapses.
So what happens when that density vanishes? Well, the buoyant force vanishes right along with it. The ship literally loses its physical ability to float. It doesn't sink slowly, it drops, like a rock, straight to the bottom in seconds. There's no time to make a distress call, there's no wreckage left on the surface. Just brutal, inescapable physics.
So what have we really learned here? The Bermuda Triangle isn't some cursed patch of ocean. It's a perfect storm of probability and physics. And you know, the real lesson here is much bigger than just this one myth.
So let's just recap the complete takedown. The whole legend is built on a statistical mistake, just ignoring how much traffic is there. And the very real disappearances? They can be explained by two key things: constructive wave interference making monster rogue waves and sudden methane eruptions that completely destroy a ship's ability to float. No aliens required?
And that's really the big takeaway. It's almost always easier to invent a mystery than it is to actually understand the complex science. And look, we all have Bermuda Triangles in our own lives, right? Problems we'd rather just blame on bad luck or some forces we can't control. But what if we treated them like a science problem? What if we actually ran the numbers, understood the variables, and applied some rational logic? The universe operates on rules, not on curses. The only real question is, are we willing to do the work to learn them?